All right, number 8. We want to rewrite this given inequality as two linear inequalities, and we want to determine if it's going to be and or. All right, so here's how you determine that. All right, so if you have absolute value, okay, and you have this less than, okay, this is going to equate to and. Okay, if you have absolute values and you have the greater than, this is going to equate to or. Okay, so that's how you will determine and or. Now remember earlier we had one with inequalities and you had to solve this problem twice. So the two inequalities that we're going to be doing are going to be the 4x plus 3, and we're going to say is less than 14, and then since it's less than, and the other one is going to be 4x plus 3, and we got to flip the sign and change the sign. It's going to be greater than negative 14. Okay, so you base the and or off what you start with. So since I started with less than, even though I flipped the sign, it's still and. Okay, so don't confuse that with the or now. All right, if I started with this with the absolute value, then it would be or automatically here. So these are going to be my two inequalities, and we want to put and in the middle. So this is going to be part 1. So we want and the two inequalities, 4x plus 3, and I can use it on my keypad, less than 14, and then we got 4x plus 3, let's say greater than negative 14. If you want to get those symbols, you can just hit this keypad button here. I'm just using the where are they? Right here. I'm just using the keyboard to type those. All right, now part 2 wants us to actually graph these two and show the shading. So I know shading is going to be in the middle, okay, because it says and. So the ones that have the shading on the outside, like this one, I would definitely throw that out. This one I would throw out. So we got 4 options. Now also, since this has only x in the equation, I know I'm going to have x equals equation, which is going to be vertical lines. So it's going to be lines like this. So this is out, and this is out. So the only one that I didn't throw out is this one, which you can kind of get by process of elimination. But let me solve it and just show you what's going on here, so you can verify. You will subtract 3 from both sides. That will go away, bring down 4x less than, this will be 11, and then over here cross that out, bring down 4x greater than, this will be negative 17. Divide by 4, divide by 4, and we get x is less than 4.8. That's about 2.75. Let's just say 2.8. All right, and then over here divide by 4. That's 16. So that'd be x is greater than 4.25, negative 4.25, or 4.3, because it's going to be negative. Okay, so these are our two x values. So if you were graphing these, positive 1, 2, we'll just say 3. It's about 3. And then over here, and I should be doing dotted lines. I keep messing up. I just do a solid line every time. And then over here, negative 4.3. So 1, 2, 3, 4. All right, this is what I should be doing. Dotted lines. All right, so 4.3 we want to go to the right, and it will actually go all the way out. But since it says and, we only want the double shaded, and this side from the positive is going to the left. If your variable is on the left hand side, this arrowhead points you the direction to shade. So from the negative, we're shading this way, shading that way. And from the positive, we're shading this way, going toward the negative. And we stop in between. That's the double shading. I mean, it actually extends all the way out on both sides, but the and tells you only want the double, the part that both sides shade. So that's how we get this picture here.